Are context graphs the next trillion-dollar opportunity? And better yet, what are context graphs? Hi, I'm Daniel Davis, co-founder of TrustGraph, and we have the word graph in the name because we've been working on this very topic, context graphs, for over 2 years now. Now, does that mean we invented them? Does that mean they're new? Does that mean they're old? Um, some of all of the above, maybe, or maybe not. They're certainly not old because this is really a subset of the knowledge graph world. And that's what led me to write the Context Graph Manifesto, link down below, which perhaps that's what brought you here. Perhaps you read it, perhaps you've read some of the other articles written about the topic. And what really struck me about most of the content and discourse around the topic was the history and real world usage of knowledge graphs was really being ignored, being treated as if this is something revolutionary or a totally new way of thinking, and ignoring the fact that this technology is in use every day at scale already, just not quite in the way that we're going to use it for AI. For instance, every time you pay with something with a credit card, it's likely going through a fraud detection system, which is querying massive graphs, billion plus, hundreds of billions of plus nodes and edges. And it has to be able to retrieve subgraphs, make decisions, in usually less than a second. The retrieval requirements for those systems is measured in milliseconds. And again, this has been done for years. The oil and gas industry is actually a major user of knowledge graphs. Another one is the medical field, medical research. There are lots of ontologies for all of that. And that's a topic we want to get to a little bit later, is that word ontology keeps coming up a lot lately. But before we can really talk about ontologies, let's level set and really get down to what are we talking about? What are knowledge graphs? Well, knowledge graph is a rather ambiguous term. It's been around for a while now, but the concept of graphs or information theory, semantic structures, semantic networks, that date back decades, as far back as the 1960s and earlier. This really comes about how it really began to scale, though, with the internet, surprise, surprise, and the semantic web, and people looking for ways to exchange information across the internet. And people starting saying, well, these semantic structures, this subject, predicate, object structure, well, that really seems like the ideal way to do that. And that's when the entire RDF ecosystem was born. And then out of that became OWL, SCOs, which I personally like, but didn't pick up adoption, although I think it may be finally seeing its moment in the spotlight now with AI. And then all the other ontology structures in schema.org. I mean, schema.org is kind of the biggest one that underpinned Google search for many, many, many years, not so much anymore. But if you built websites going back several years ago, you know that how you improved the SEO for the website was by enhancing it with the schema.org metadata. And if you still go to the Google search dashboard, and you'll still see enhancements and you'll still see documentation, which immediately sends you to the schema.org ontology on how you add that information to your website to, like when you would Google, say, a company that has, actual products, a product catalog. And then when you do the Google search, all of a sudden you actually see the products down below. Well, that's coming from the schema.org ontology that those people have added to their website. Now, I've gotten ahead of myself a little bit. The semantic web, property graphs, knowledge graphs, again, it's really all about the triple: subject, predicate, object. But you've probably heard a lot of people talk about that at this point. So let's actually dive into example. Property graphs, I think, are a little bit easier to understand. Property graphs have really been popularized by Neo4j, who is the market leader in this space. And they pioneered this kind of property graph approach. And they have their own query language and structure called Cipher, which there was a movement to standardize it called Open Cipher, but it has now become an ISO standard called GQL. And I have it on very good authority. That's how you say it, GQL, kind of like SQL. Now, interestingly, property graphs are kind of are kind of the opposite of the approach of the semantic web people or the semantic web approach, and that you're not as thinking about information exchange. You're really thinking about how I'm going to structure data for myself that I want to be able to retrieve, so that if I have a subject predicate object, I can append properties to each one of those individually. I can append properties to the subject, the object. That makes sense because, say in my example of in the Context Graph Manifesto, I did a simple one as, Alice is mother of Bob. Well, if Alice is a subject and Bob is an object, there's lots of additional information I want to maybe include about, Alice and Bob, who they are, where they're from, how old they are, all sorts of information, who they're employed by, where they live, what's their email address, all sorts of information. And you think, though, is mother of? I would want to add properties to that. Let's think about it from a database perspective. We store all sorts of metadata when we get to data at scale. It could be things as mundane as when was the last time this record was accessed? How many times have been accessed? How many times does this appear in this data set? When was it last updated? When was it created? All sorts of really mundane stuff like that you can glean huge amounts of information from, depending on how it's labeled. And more on that later. On the opposite side of that, though, we kind of have the RDF ecosystem, which is very different. And I love to use an example that the TrustGraph co-founder Mark created for me to help me understand RDF, because I first looked at RDF and went, I don't get it. Unfortunately, the resources for learning RDF, if there's a good one out there, somebody send it to me, please. I looked a lot, and it doesn't help that the RDF ecosystem isn't explained very clearly, because you'll see things like OWL and all these other ontologies, and you think, well, how does this play into RDF? And then you think, is RDF the singular thing? And then you see there's all these different ways of representing RDF, like RDF XML, JSON LD, Turtle, which we're going to predominantly use, or even in triples. And that's just the tip. There are quite a few other ways of representing RDF knowledge. And then OWL is really within that ecosystem, and then you have ontologies that are within the OWL ecosystem. It can be a lot. And some of these structures have very sensitive syntax. Turtle, for instance, can be sensitive to indents, white spaces, where periods are, commas, semicolons, etc. And it's really easy to get that wrong. And there aren't many syntax validators. So I can understand why people are turned off by RDF. They look at it and go, I don't understand it. I don't understand why there's all these URLs over the place. And they kind of miss out on all the capability of it. So let's start with a really simple example. We have 3 statements. I'm not going to use the word fact because of something else we're going to get to a little bit later. Fred lives with Hope. Fred is a cat. Fred has 4 legs. Okay? 3 really simple statements. So how would we build that into an actual RDF representation? There's a lot of things that we have to do here already. There's all these classes and types. What we have to. Fred is a cat. Well, what's a cat? We have to establish all this information, because the idea is that we're going to be taking this information, removing it from its in situ context, but trying to retain all that in situ context, which means there's a lot of structuring that has to go on. That means we need to create properties, we need to create types, and then we need to have create objects. And we end up kind of with all of this stuff so that we get down to, all of this. And you go, we need all of this just to understand some information about Mark's cats? And the answer is yes, because those three simple statements that we started with, there's so many assumptions that go into that when we take those statements out of its original context, its in situ context, we can't really make those assumptions anymore. For instance, I like to talk about hope. Hope is an ambiguous word. Hope can be a name of a person, or we could be saying, Fred lives with hope. Does that mean, you know, Fred is a hopeful cat? Was he once not hopeful and now he is? And also another one is that, what did we say? We said that Fred has four legs. Well, if we take out the statement about Fred being a cat, well, there's a lot of things that can have four legs that could also be called Fred. And I know you're thinking, well, that doesn't seem realistic, but have you been to IKEA lately? I can see them naming a table Fred or a chair. Chairs have four legs, tables have four legs, lions have four legs, dogs have four legs. Lots of other things have four legs. Without all this information connected together, we can't make those assumptions, and we could make incorrect assumptions about how to interpret this. And yes, this is actually what ontologies do. And you're probably thinking, this is ridiculous. Why would I do this? To talk about cats. You're right, except that when we hit scale, and that's one of the really important points here, is that in the last 2 years, so much of the work that's gone on in the AI field around RAD, although I think that term is really now beginning to shift towards context engineering. So much of it was around demos and proofs of concept, and those typically revolve around small data sets. Whether it's one document, I see people use like one data set, or a lot of times people use a book. Like say, hey, here's this 600-page book. Look at how I can retrieve information from it. And those demos and they look pretty good. But what didn't happen is when an enterprise took this with their massive data sets, it didn't really go from the POC phase into production. And why is that? Because of problems like this, disambiguation, where you can't just take a text chunk out of its in situ context and still be able to retain that sort of information. Another good example of that is if we think about how books are written, or just how especially like a novel. Let's just talk about a novel, for instance. And say we're doing text chunking, and we're chunking maybe a paragraph at a time or two paragraphs, and we're trying to understand what's being talked about in some of the characters. Well, how are those characters going to be likely referred to if we just take in the middle of a chapter and we grab two of those paragraphs and take them out? What are we going to find? We're probably going to find only pronouns. If all the characters have been previously referenced, it's probably going to be he, her, they, and just other pronouns referring to the important individuals or important objects that are being discussed. I mean, that's how we're taught to write. I mean, matter of fact, it's quite awkward if you keep, like, for instance, with Alice and Bob, if I were to use Alice and Bob in every single instance of talking about them, it becomes very, very awkward. And that's just not how we speak. But if we just take those text chunks out of its in situ context and all we have are pronouns, well, how do we know who's being referred to? If we just use a vector embeddings approach alone, we're absolutely not going to. And that's why people are now talking about context graphs. And what about, a year ago, maybe people were talking graph RAG. Now it's moved on to more of a context graph way of thinking. And you're thinking, well, How do graphs handle this? Well, you can probably see now with what we're talking about with property graphs and what I'm showing you now with RDF that we can append to those he's and she's and theys, we can append information that says, well, this relationship talked about in this paragraph is in chapter blank on page blank of this book. Well, let's say X and Y. I don't know why I said blank. And so now we know it's in chapter 2 of this book, and we know what chapter 2 is about. We know who it's talking about. So in a graph structure, there would be connections. All of a sudden, this relationship from he would be connected to, well, this is a discussion of these characters in this place. So now when we retrieve a subgraph, that information would be included. And that actually goes to an interesting point, which I'm going to talk about a little bit more in detail later, that I've seen some people talk about how context graphs are just the thing that you give the LLM. I don't agree with that. Those are just subgraphs of larger context graphs. And again, this is how the knowledge graph industry has worked for decades. You don't really partition graphs. You could have a trillion node graph, and it's just about how you query it, which is about how you structure it, which is kind of how that term ontology is getting conflated in here now. So again, not necessarily new ideas, but just a slightly new way of thinking about, some of this stuff. So that's, that's some cats. Let's talk about a couple other examples of disambiguation. I want to talk about this idea of truth. I know I have a very, how shall I say this? People are not all that people tend to push back hard about what I'm about to say, but I hope that this example that I'm going to give you will at least give you pause to understand the perspective and potentially just, take a deep breath and go, maybe there is a different way of thinking about this. When you look at information, I believe the whole concept of ground truth is illusory. It's the mirage of the oasis in the desert. It's something that we as humans so pine for. We so desperately want these concrete truths, these absolutes, and our world just doesn't seem to behave that way. And one of my favorite examples is one that seems absurdly simple, and that's the observation that the sky is blue. Think, well, that's a fact. That's simple. Is it? Let's think about all of the assumptions that went into stating that the sky is blue, because the sky is not always blue. First of all, the sky is blue here on Earth with our atmosphere. You've seen the images of Mars. You've seen some images of Venus. You've seen images from the moon. That sky, not blue. So when I say the sky is blue, that's assuming that I'm talking about being present here on Earth. Sky is also only blue when it's daylight, if it's clear and you can see the sky. Also, there are places around the Earth where it's not always so blue. Matter of fact, here in the San Francisco Bay Area, we're blessed with these very reddish orange sunsets because of our atmospheric conditions. I've been, when I grew up in the southeastern United States during very, very severe weather, often sometimes before you would see tornadoes, sky sometimes turns green. So the sky isn't always blue. There's a long list of assumptions needed to justify saying the sky is blue from. I'm talking about Earth. I'm talking about on a clear day, during daylight hours, not night, not sunset, not dusk, the right weather conditions, the right atmospheric conditions, the right viewing angle. All those things have to be in place for the sky is blue to be a valid observation. Another one I thought about was, say I walk outside and I'm standing on the sidewalk of a busy city, and all of a sudden I feel water hitting me, and I go, hmm, it's raining. That's an observation. To me, it is true. I am getting hit by water that is falling from above me. It must be true, right? Well, perhaps somebody on the 10th floor who's working on a pipe that is leaking knows that it's actually water leaking from a pipe that is now landing on my head. So, what is absolute truth? My truth is that it's raining. The plumber's truth is that, well, it's a leaking pipe. So, if you ask me, I'm going to swear up and down it's raining. However, if I walk to the end of the block, I might go, Is it not raining? Was it only raining there?" But if you just take that observation, when I said it's raining, and you take it totally out of its in situ context, how do you manage that? Because I wouldn't have been lying. That was my observation at that point in time. All of this information has to be structured together for us to be able to understand what's really going on in our world. Another example of this is time. Time also opens up an entirely new way of thinking about observations and assertions. Again, I didn't use the word truth. I have a bit of a theorem that, and again, I don't like using the word truth. I think we have static observations. And what that means is that if I continue to observe a phenomenon over time and the observation is the same, well, that's something that we can say is static and is unchanging. And I believe that's about as close to we can come as establishing ground truth. But what we can start thinking about is how fresh is the data? Is the data still useful? And a great example of that I did talk about in the Context Graph Manifesto is how the perception of the UFO, UAP, and alien phenomena has changed during my own lifetime. I, growing up in the 1980s, remembered that if you talked about UFOs and aliens, you were quickly branded as crazy. I still remember being in high school in the late 1990s and being a huge fan of the Exiles, and not really being a good idea to tell people that because you would also get branded as very weird. Fast forward to now 2026, and it seems that the public at large is now at the point of, are they ever going to admit this stuff is real? I mean, come on, everybody knows it. But the perception has changed. But if you look at the underlying data, there have been researchers going all the way back to the 50s and 60s and working very diligently, doing really good research. And probably a lot of you never heard of. I still think the best researcher on the topic is the late Jim Marrs. I always recommend his books to people. Very diligent investigative journalist who always took an evidence-based approach. And if you look at all of his books and all the evidence he presented, it was discounted up until now. And now you have whistleblowers coming forward that are repeating the same observations. So now that people are going, well, it appears this data is still fresh. Or if it's repeated observations that don't change, does that make it truth? But the bigger point is that if you were to look how people would have scored the freshness over time, I don't think people would have considered that data very fresh in the 80s and 90s. They would have considered it to be not valuable or stale or incorrect or just not worth considering. Where now it appears that data collected all the way back in the 70s and 80s and even earlier is just as fresh now as it was then. And that's really what temporal relationships and context graphs are going to be about. It's not going to be about timestamps. It's going to be about way more than that. And how can it be about way more than that? And this is another topic in the context graph discussion that is getting really ignored, is the decades of very, very mature and robust graph analytics techniques. Again, if you're working in the fraud detection world right now, you're probably screaming at me going, all the different ways that you use graphs and all the kind of algorithms you use to find relationships from not just simple things like how many hops do I want to make in my relationships, but do I want to I have two relationships, like I have Alice and I have Bob. I want to find out how they're related. Do I want to take the shortest path possible? Or do I want to take the scenic route and find the longest path possible that connects them? You can learn a lot from doing those approaches. But then you can look at how information is clustered together. You can calculate the density of those clusters. You can then start to create communities from those and then which is a little bit, how vector embeddings even work. And then one of the most important use cases is anomaly detection. When you have all these clusters and you calculate the density and you find the communities, and then all of a sudden you have this connection that's kind of off on by itself. What's that about? Well, in the fraud detection world, that's typically how transactions get declined and things get flagged. You go, whoa, wait a minute, this doesn't look right. Also in the cybersecurity world, whether it's network monitoring, endpoint detection, when something gets flagged, it's usually because an anomaly has been spotted. This doesn't fit with the normal patterns. So again, these are techniques that have been used for decades. They are in use at scale today. They are not new. However, we haven't really begun to apply them yet to the concept of a context graph. Even within TrustGraph, we're still doing very basic, being able to determine how many hops you want to make when you retrieve subgraphs. And I guess this is a good point also to really emphasize that context graphs are not just these things that you give to an LLM for a response. A context graph is an AI optimized graph. It's it's a graph structure that is designed specifically for use with AI. That's what a context graph is. So when you actually provide context to the LLM, you're just querying the context graph and then restructuring it or not restructuring it for the LLM. So again, what does that process kind of look like? So we just send in a request, we query the graph, and then we use whatever graph analytics methods we want to use. Do we find first degree relationships, third degree? Do we want to take the scenic route and find how it's the longest way we can possibly connect these? Do we want to find clusters? Do we want to find anomalies? And then we take all that information from these subgraphs that we've retrieved and we reconstruct that for the LLMs and produce better responses. Now, interestingly, there's a lot of question. Well, this comes up a lot, actually. People are trying to get very clever with how they structure information for LLMs, to which most people, I think, what was the latest one? There was some acronym that people came up with. It was kind of like this YAML, JSON light sort of thing, and I've already forgotten what it was. It didn't have much staying power because you can already see I've already forgotten it. If you remember what it was, put it down in the comments. If LLMs haven't seen a lot of it in their training data set, they're probably not going to do a very good job of it. But, it's important to remember LLMs can not only read human readable text, but also machine readable formats. In fact, I think they're probably better at the machine readable formats. And is that really counterintuitive? Because machine readable formats have more structure, more patterns, more rules. So is it surprising? And what I'm really getting at now is, how do we present the data to the LLM? Once we've retrieved the subgraphs, once we've done the graph analytics, we've done the calculations, how do we present that information back to the LLM? We could try to repackage it as text, but we've actually done work on this with TrustGraph. It didn't seem to work very well. So then we thought, well, bulleted list and creating, some sort of symbolic way of creating relationships. It did a little bit better, but what we found the best, and this is an example kind of sorted in kind of light in triples format. I took out the URLs just to not hurt your eyes. We found that retaining an actual structure that it knows provides additional information that gives the LLM even more understanding of what's going on. And why is that? So let's think about it. If I tell it, here's a set of triples, an RDF structure in the in triples format, the LLMs know what RDF is. They know the implication of RDF, how it's used, what in triples is. So what it sees is not just Alice is mother of Bob. It sees, well, Alice is a subject, Bob is an object, and his mother of is a property. It starts thinking about how these things would be structured together, that there's all this additional context to just the structure alone. The structure alone provides information. Whereas if I say Alice is the mother of Bob who works at company X, isn't there in this structured environment? And again, we see this happening. Where did we see really big advancements in 2025 in LLM? We saw it in coding. Coding is very structured with repeatable patterns, and the patterns themselves convey information. The structure itself conveys information. So why are we surprised that taking data, knowledge that we might have described in a paragraph, and now providing it in a data structure that the LLM knows provides better results? We shouldn't be surprised at this at all. And this is really where we're going with context graphs. This is where we're going. This is what it's going to end up being all about. And this, of course, is something we've been working on again at TrustGraph for 2 years now. And this is not theoretical. This is not a presentation. This is not just videos, because if you're here, you see all the other demo videos here. You see all the old tutorials, and there's a lot more of those coming soon. Because TrustGraph can build context graphs today. We have users that have built billion plus node and edge context graphs. We have people building their entire products with TrustGraph. This isn't theoretical. This works today. And I hope this helps some of these sets the record straight on some of these topics and gives you some additional context on knowledge graphs and how context graphs are just an evolution of a lot of mature topics that we've all been waiting for. And I just realized the one more thing: ontologies. The word that keeps getting thrown around so much in this discussion. Ontologies, again, are really a semantic web concept. And what was the semantic web about? The semantic web is about exchanging information freely in a common format. But what is an ontology really? It's just a domain-specific, often, way of structuring knowledge or context. We want to use the word context for machines, for storing in a graph structure that you can then retrieve with an autonomous software system. So the concept of ontology is far from new. There are thousands upon thousands upon thousands of ontology that are in use today. Not just OWL, not just SCOs, not just schema.org. There's GSV1. I think there's one in finance called FIBO. If you look in the medical field, there's tons of them. I know in the defense and intelligence world, there's a lot of ontologies for exchanging information between disparate systems. There are so many ontologies. So this idea that you have to custom create ontologies, well, there's already thousands upon thousands upon thousands of ontologies that are out there free to use, that are just sitting out there, that people do use, that are industry standard in a lot of domains. As a matter of fact, TrustGraph allows you to take an ontology that you can take from somewhere, ingest it in, and it'll start building your context graphs to that ontology with the retrieval automatically tuned to that ontology as well. There's lots of these out there. There's even ones on the BBC's websites for recipes. Believe it or not, the BBC has an entire website dedicated to free ontologies that you can go and grab. So why are people talking about ontologies? that's another discussion. Talk to me on Discord or on LinkedIn, on Twitter. All my links are below, and we'll have a little bit more of that discussion. But between me and you, ontologies are nothing new. There's lots and lots and lots and lots and lots of them out there already. And we don't need to reinvent the wheel when it comes to ontologies. There's going to be some slight tweaks to how we structure data for context graphs, for optimization for AI, but there's no need to start building lots and lots of ontologies from scratch. There's already lots of them out there, and they already are in use today. So much more coming soon.